Okay, we've got a couple kite theorems. And when we talk about a kite, I want to define two things. I want to define what we call a vertex angle and a vertex diagonal and a base diagonal in a kite. So remember, a kite is just two adjacent sides congruent. So two pairs of two adjacent sides congruent in a quadrilateral. The reason I chose these terminologies is because we're going to call the base diagonal, because we're going to think about this as a two isosceles triangles that share a side. It's the best way to think about kites, is to remember that they're just two. A kite is just two isosceles triangles that share a base. So the reason we call it this one the base diagonal is because it's the base of the two isosceles triangles, and then we're going to call the other diagonal the vertex diagonal. We're going to call it that because the in a isosceles triangles, these 2 points, we'll call them B and D, are vertex angles of the isosceles triangle. So we're going to call that the vertex diagonal, the diagonal that connects those two. So the first theorem says the diagonals of a kite are perpendicular. So that means that BD and AC are perpendicular or meet at a right angle. And then the second theorem is the vertex diagonal, so BD, of a kite bisects the base diagonal, AC. So the reason I put these together is because the proofs are identical except for the last step. And so I thought it'd be good just to go ahead and include both of them. So when we do this, we know that A, B, C, D is a kite. That's what we're given, which means that AB is congruent to BC, and AD is congruent to CD by definition of a kite. Right, the definition of a kite says consecutive or adjacent congruent angles, or pairs of adjacent angles are congruent, or sides are congruent. And so now that we have these two, so basically we have what we're looking at here. We want to prove that this is true. And so the way that we're going to do this is by first looking at this picture, which is without AC drawn in. And so if we take a look at that, then we can easily show, using the fact that BD is congruent to BD, that triangle ABD is congruent to triangle CBD. Right, and that's just by side, side, side. Sorry, this should have been reflexive property. And then we know that triangle ABD is congruent to triangle CBD, and that's because we had side, 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 and then side. And so that's by side, side, side. From there, we're going to be able to show that angle ABC is congruent to angle CBD by CPCTC. It actually is true on the other side as well. ADB is congruent to CDB, which we'll get to in a second. And so now back to our original drawing, we'll call that middle point E. We now know that these two angles are the same, so we can claim BE is congruent to BE by reflexive property. And so by side angle side, we can prove those small triangles congruent. So triangle ABE is congruent to triangle CBE by side angle side. And then that's enough to show that angle AEB and angle CEB are congruent to each other. That's CPCTC. So we've got two angles that are the same, but it turns out they make up a straight line. And so we actually have a theorem for that. And so we say that angle AEB and angle CEB are are supplementary. And that's because linear pairs are supplementary. And so what we've shown is that AEB is congruent to CEB and AEB is supplementary to CEB. And then that tells us that angle AEB and angle CEB are right angles. And that's because if two angles are congruent and supplementary, then they are right. And then finally, that's enough to show that the AC is perpendicular to BD. And the reason for that is just definition of perpendicular lines. Okay, so these first two theorems tell us that not only are the diagonals perpendicular, they meet at right angles, super helpful when solving problems, but also the vertex diagonal of the kite bisects the base diagonal, which we can prove. We didn't put it in here, but instead of these steps, once we showed this, we could have also said that AE is congruent to EC, which proves that BD bisects AC. So that would have been the last step for the proof of 6-17.1. Okay, we also, and the reason I put the 0.1 is just following along with what your book is. We also have these two theorems. The base angles of a kite are congruent. We're going to call these two angles the base angles, A and C, because they are where that base meet. And it does turn out those are always congruent. The proof of that actually goes back to this step. If you remember that step, we showed that ABD is congruent to CBD, thus A must be congruent to C by CPCTC. And then the last one is the vertex diagonal bisects the vertex angles of the kite. And so that means that these two angles are going to